Okay, so this question is actually based on functional equations where they have given f of x plus y is equal to f of x plus f of y plus f of x into f of y. And the second relation that they have given is f of x is equal to x into g of x. And the third one that they have given, limit extends to 0, g of x is equal to 1. And then which of the following statements are true? So first we need to talk about the differentiability of the function f of x. So let's start with that. So let me write all the given relations. So they have given f of x plus y is equal to f of x plus f of y plus f of x into f of y. The second relation that they have given is f of x can be written as x into g of x. And the third relation that they have given is limit extends to 0, g of x is going to be equal to 1. Okay. So first let's talk about the differentiability of f. So that we are writing as f dash of x. So using the definition of the differentiability, we'll be writing this one as f dash of x can be written as limit h tends to 0, f of x plus h minus f of x upon h, right? So now here we need to find out what is f of x plus h so that we can directly write it from here. So in the place of y, substitute h. So we are going to get f of x plus h is equal to f of x plus f of h plus f of x into f of h, right? So from here we can write the value of f of x plus h minus f of x as 1 plus f of x. If you take f of h common, 1 plus f of x into f of h, right? So that is the value that we'll be using here. So in the place of f dash of x can be written as, this is limit h tends to 0, and this value can be written as 1 plus f of x multiplied with f of h upon h. So now as we are applying the limit for h tends to 0, that means with respect to h tends to 0, so this will behave like a constant which can be taken outside of the limit. So we'll be getting this one as 1 plus f of x multiplied with limit h tends to 0, f of h upon h. So now we need to talk about what will happen to this limit h tends to 0, f of h upon h, to identify whether f dash of x is going to exist or not. That means f of x is going to be differentiable or not. Okay. So but here for that one we are going to use that given relation, f of x is equal to x into g of x, and limit extends to 0, g of x equal to 1. Okay. So let's use that one. They have said limit extends to 0, g of x is going to be equal to 1, right? And again we can write limit extends to 0. This g of x can be written as f of x upon x according to the question, that will be equal to 1. So using this one, we can directly tell f dash of x is going to be equal to 1 plus f of x into this limit h tends to 0, f of h upon h, whatever we have here, that is exactly same as this one, right? Which can be taken as 1. So this is going to come as 1 plus f of x, right? So finally what we got here, f dash of x value is going to be equal to 1 plus f of x. So now from here we can find out what is going to be this f of x by solving this differential equation. So let's proceed with that. So we have f dash of x is equal to 1 plus f of x. So here we can write d f of x upon 1 plus f of x is going to be equal to dx. Now integrating both sides, so we'll be getting this one as ln 1 plus f of x is going to be equal to x plus c, right? So to find out that integral constant c, we need some interpretation here. So for that one, we already have this given relation again, f of x plus y is equal to f of x plus f of y plus f of x into f of y. So in this, if I put x equal to 0 and y equal to 0, what we are going to get? So if you put x equal to 0 and y equal to 0, we'll be getting f of 0 is going to be equal to 2 times of f of 0 plus f square of 0. And if you solve from here, we'll be getting f square of 0 is going to be minus f of 0. And this value is possible only when both of them are equal to, this is possible only when f of 0 equal to 0, because we are taking real functions. Okay. So that means the value of f of 0 came as 0. So now we are going to use this one and the relation that we got here, ln 1 plus f of x equal to x plus c. So substitute x equal to 0 in this expression, we are going to get ln 1 plus f of 0 is going to be equal to 0 plus c, which will ultimately will give you c equal to 0. So from this, we can directly find out what is that function is going to be. So that is ln 1 plus f of x is going to be equal to x. So if you remove this ln, we are going to get 1 plus f of x is going to be equal to e raised to x. And from here, we will be getting f of x is going to be e raised to x minus 1. So this is the function that we got here. So now directly we can say e raised to x is a differentiable function. So e raised to x minus 1 is a differentiable function. So that is what your option A says. Option A, they are saying f of x is a differentiable function. So that one is correct. And then in the option C, that they have given the value of f dash of 0 equal to 1, so that you can directly find out here. So f of x is going to be e raised to x minus 1, and from here we are going to get the value of f dash of x equal to e raised to x. So f dash of 0 is going to come as e raised to 0, so which one is equal to 1. So option C is going to be the correct answer for this. And option D, they have given f dash of 1 equal to 1. But f dash of 1 here is going to come as e raised to 1, which is equal to e. So option D is going to be a wrong answer. Okay, so for this one, so far we got answers A, C as the right answers. Now, the second option is actually talking about g of x. So let's see for the calculations of g of x here, right? So we are going to use that given relation again. F of x is given as x into g of x. F of x is given as x into g of x. And the second relation that they have given, limit x tends to 0, the g of x is going to be equal to 1. Okay. So now let's interpret using g of x. So what we can write here, g of x can be written as f of x upon x, but this is valid only when x is not equal to 0, right? But when x equal to 0, we cannot write this one. So in option, right? So in the option B, they mentioned if g of 0 equal to 1, then g is differentiable. Then g is differentiable. So this is what the option B says, right? So when x equal to 0, they have already given, with respect to option B, they have given this value is going to be 1. Okay, so now let's see whether it is going to be differentiable or not, right? So again, we are going to use the similar type of relation only. So to find out whether it is differentiable or not, we will be using exactly the same relation. So the only problematic point for g of x is going to be 0, right? So it is going to be differentiable everywhere. How this is differentiable? Because g of x can be written as f of x upon x, and f of x is nothing but e raised to x minus 1 upon x when x is not equal to 0, and this one is going to be 1 when x equal to 0. So e raised to x is a differentiable function, and this everything is going to be differentiable here. So g of x is going to be differentiable for every x except 0, right? Now at x equal to 0, we have to find out. At x equal to 0, we have to find out what will happen. So that is the only problematic point. So then we are going to find out what will happen to g of x at x equal to 0. Okay, so that means we need to find out g dash of 0. So again, using the same type of relation here, we are going to get, this can be written as limit h tends to 0. So this can be written as g of 0 plus h minus g of 0 upon h. So that can be written as limit h tends to 0. So this is going to come as g of h minus g of 0 is given as 1 upon h, right? So from here we can write this is equal to limit h tends to 0. So now this g of h can be written as f of h upon h, that is nothing but e raised to h minus 1 upon h minus 1 upon h, right? So this is what we are going to get. And if you simplify this one, we'll be getting limit h tends to 0. And if you take the LCM, so that will be e raised to h minus 1 upon h square. So this is what we are going to get as the value of the g dash of 0. So now we need to find out whether this is going to be differentiable or not. That means if this limit is going to exist, we can directly say g of x is going to be differentiable at the point 0. Otherwise, it is not differentiable. So let's try to find out that. So we got g dash of 0 came out to be limit h tends to 0, e raised to h minus 1 upon h square. So here you can directly see the right hand side is of the form 0 upon 0. So we can apply the L'Hopital rule. So apply the L'Hopital rule here. So what are we going to get? So this can be simply written as limit h tends to 0. So this one is going to give you e raised to h minus 1 upon 2h. So again, this is of the form 0 by 0. So we can apply the L'Hopital rule one more time. So this is going to give you limit h tends to 0. The differentiation of numerator will be e raised to h upon differentiation of the denominator will be 2. And this one is going to give you the answer as 1 by 2. So that means we got g dash of 0 equal to 1 by 2. That means the limit exists. So that means it is going to be differentiable at x equal to 0. So g of x is going to be differentiable at x equal to 0. And we already know this is differentiable for all x values which are not equal to 0 also. That means your g of x is going to be differentiable for every x, right? Every x in the domain that we have here, every real number that we are having as the domain of the g of x is given as real numbers only. So g of x is going to be a differentiable function. So that actually makes option B also correct answer. So for overall, so what are the correct answers that we got for this question? That is option A, that is f is differentiable everywhere. And we got option B, if g of 0 equal to 1, then g is going to be differentiable everywhere. And we got option D, f dash of 0 is going to be equal to 1, and option C is going to be none. Okay, so the answer for this question is going to be A, B, D.